Okay, for this project, I chose to look at a PhET simulation on the www.phet website. I chose a biology simulation over neurons and ion-gated channels. For this simulation, it has a couple of related concepts that the students need to be aware of while they're performing. It is a biology and human anatomy topic that they will be exploring. They should have a little bit of background in neurons and definitely some background in cells, so I would recommend it for human anatomy just because they've already covered those neurons and cells topics that they will be further exploring in this activity. Okay, this simulation works by, you can zoom in and out to see those ions in those gates a little bit better. Over here to the legend, you can see that it tells you what are the potassium and what are the sodium ions. It also differentiates the different types of channels that you can see here on these edges. You can choose to show all the ions or just some. You can choose to show the charges, the concentrations, and the potential chart. So if I show all of the ions, and show the charges, you can from here stimulate the neuron, and you can see a rush of movement in and out of the cell using those gates. You can also view in fast forward to see it quicker, as well as in slow motion if you want to really have your students take a look at what is happening during the simulation. So for some questions for student investigation, these are adapted from the given objectives of the simulation. One good question would be, what is the difference between leakage channels and gated channels? That's one that they can definitely see clearly in the simulation. How is the charge of the neuron affected during an impulse? Again, if they have the charge selection on that drop-down menu, they can see just how different the charge of the neuron becomes. How is the simulation not exactly like how it appears in real life? This is an important question with any simulation because we want to make sure students are aware that there are shortcomings to any simulation compared to how it really occurs in real life. And then finally, what is the order of events for this action potential in the neuron? That just kind of is a little higher level thinking so that students have to write in their own words what the order of events of this action potential is when it happens in their bodies. This simulation does give students a chance to analyze data in two separate ways. First, there is a chart that shows membrane potential versus time, and then there's also that section where you can see the concentrations of the ions. Okay, as far as data collection goes, just to kind of show you on the actual simulation what the students would be looking at. So as you can see here on the show panel, they have the charges and concentrations, so you can see exactly how the charges are at before the pulse and after the pulse. So if you go ahead and click that nerve impulse, students can see how that charge is changing as it goes. So it continues to move, and while it's moving, you can't stimulate the impulse again until it gets back to where it was at the beginning. Then you can stimulate it again and see that change. For the chart, you can see this potential chart button right there. If you want to keep the charges and concentration showing, you can, but then you can also click that membrane potential chart. So it's not doing anything right now until you stimulate the neuron. It'll show you as time goes on. And then right when that nerve impulse hits, it'll bump up and then come back down. And then notice again, you can't stimulate it again until it's back to the way it was. And then you stimulate that neuron to see that peak once again. This activity can be utilized in my future classroom, specifically in a human anatomy classroom over the nervous system unit. That's usually in the second semester. And like I said, they normally have some background in neurons and cells by that point. This activity could be used as an introduction to ion channels, and it can also be related back to concentration gradients, which is another concept that had been touched on previously in the class. And for the project, they could work in a group to explore and answer discussion questions over the simulation. And then at the end of the class period, they can present their findings to the rest of the class. They could choose how they would like to do that, maybe making their own graph of an action potential and explain what happens at each step of it, or something similar. So that's the simulation.